So welcome back, everyone. Here is a supplementary problem that will help us with two-way tables, and there's going to be a little bit of a difference in this one than what we did in the notes. Primarily that this one is going to use proportions or percentages instead of counts. So that's going to be a little bit different, but you're going to see that the way these things react and how you build them is pretty much the same. So the problem here is, according to a July 2023 survey conducted by a national research center with 1,500 randomly chosen U.S. households, 49% of households had a dog, 35% had a cat, and 24% had a dog and a cat. Use these survey results to answer the following. Well, before I answer anything, I'm just going to go ahead and define some variables. So I'm just going to let C be that a person has a cat. And I'm just going to use D to represent has a dog. All right, so this is going to spare me having to write out a bunch of words all over the place. So we have a two-way table which we'll start with, and you have dog and no dog, cat and no cat. So this would represent D, and this would represent D complement. This would represent C, and this would represent C complement. We don't have any labels for totals, so here we go. We'll put totals here, and since this is going to be in percentages, I'm going to just go to the decimal equivalent, and when I'm through with everything, the grand total for this should be 1, which, since this would have to be a sample space of some kind, that everything has to add up to 1. And what I want to do is start out with the first joint probability of a person owning a cat and a dog. That would be 0.24. So 0.24 goes here. And let's see, that's going to be for both, but we can also kind of look at what is the proportion of households with a dog. Well, there are two ways to own a dog. You can have a dog and a cat, or you can just have a dog without a cat. So those two things have to add up to 0.49, which is this number right here. And since we know that there are two ways to own a dog, either with a cat or without a cat, or means plus. So this plus whatever this joint probability is, a dog and no cat, should add up to 0.49. So this would be 0.25. Also, the probability of owning a dog is 0.49. That means the probability of not owning a dog is 0.51. It has to be, because that would be its own little sample space, and that would then have to add up to 1. So let's do the same thing with a cat. The probability that somebody owns a cat is 0.35 up here. So that would go out here, 0.35. All right. So there are two ways to own a cat, either with a dog or without. That means two things add up to 0.35. That means this has to be 0.11, because those two would add up to 0.35. By the way, this total 0.35 would have to add up with whatever this total is to make 1. So this out here, the probability of a no cat is 0.65. So that means that we can figure this out easily, either going this way or this way. This would have to be 0.40. That would make this add up to 0.65, and that would make this add up to 0.41. Now, one thing I'm not doing that we have been is putting the zeros in front of everything. So I'm just going to go ahead and do that so everybody will be comfortable with the notation. It's the same thing, but it's just the way that we normally do things. So there's a complete table, and we can answer just a boatload of questions off of what we've written there. So let's move to the Venn diagram. And remember how we've done the Venn diagrams. First of all, let's call this owning a dog, this owning a cat, and we always work from the intersection on out. And that's where people own both. And so that would be 0.24. And I'm going to leave the zeros off here because it's just going to be hard to fit. Okay, so remember that this whole circle is the probability that a person owns a dog. And remember that that can be handled in two ways. Either they own a dog and a cat, or they own a dog and no cat. Well, the total for dogs is 0.49. So what do I add to 0.49 to get 0.2? What do I add to 0.24 to get 0.49? That would be 0.25. See how this plus this together make the 0.49 that we had up here. And we can do the same thing with a cat. 35% had a cat. We know 24% of it. That means this has to be 0.11 because those two things add up to 0.35. So all we have to do now is to get the fourth joint probability, which we know to be 0.40. But let's pretend we just don't know that. So 0.11 plus 0.24 is going to be 0.35, and then this will be 0.60. All three of those add up to 0.60, so this has to be 0.40, so that all of these things together add up to 1. So now we've got a complete Venn diagram. We have a complete two-way table. We should be ready to go to answer some questions. So let's see what we have for questions. All right, for number 2, what is the probability, and I'm going to go with a different color, that a randomly chosen household has no dogs and no cats? I'm going to go ahead and use the notation. This is probability of a dog complement and cat complement, which is this: no cat, no dog. So that's just going to be 0.40. How great, there it is. And it was not something that was given to us in the problem. We completed this and we completed this and we found out what it was. What is the probability that a randomly chosen household has a dog or a cat? Okay, well, we are going to use the general addition rule for that because you can own a cat and a dog at the same time. So these events are not mutually exclusive. So this is the probability of a dog or a cat. That'll be the probability of a dog plus the probability of a cat minus the probability of both, dog and cat. And those are all available up above. So the probability of owning a dog is 0.49. The probability of owning a cat is 0.35. And the probability of owning both is 0.24. And when you total up everything, that is going to be 0.60. All right, now if you want to get this from the Venn diagram up top, all you have to do is add up this, this, and this. And we've already seen that that's going to give us 0.60. Or right, so 0.25 plus 0.24 plus 0.11 equals 0.60. And the reason that I can do that is you'll notice I'm not double counting that 0.24. If I were to do it here, I would double count it. But here, all I have to do is count this, this, and this, add them all up because it's, or there's 3 ways to own a dog or a cat. You either own a dog alone, or you own a dog and a cat, or you own a cat with no dog. So very easy. Now this is going to be an interesting one. What is the probability that a randomly chosen household has no dog and no cat, or no cat? All right, this is going to be the same formula as up here, but watch how we'll have to change it. And I think I'll just go with a different color for fun. So this is going to be the probability of a dog complement or cat complement. All right, it's going to be the same formula except we're going to throw in some complements. So this is the probability of not a dog plus the probability of not a cat minus the probability of not a dog and not a cat. Interesting. We know all of these things. The probability of not owning a dog is 0.51. The probability of not owning a cat is 0.65. And the probability of not owning either one is 0.40. And if we put those all together, we will get 0.76. There it is. All right, let's see what we have for the rest of these. What is the probability that a randomly chosen household has a cat and no dog? All right, cat and no dog. Let's get this back down where we can see it. Here is a cat and a dog. Here is a cat and no dog. So this will be the probability of no dog and cat, which is 0.11. And what is the probability that a randomly chosen household has a dog and no cat? Here is dogs. Dogs go down, cats go left to right. So a dog and no cat is the 0.25. So probability, use the notation of dog and no cat is 0.25. So anyway, I hope that you found that interesting, informative. It's a little bit of a difference when you look at things using just the proportions instead of counts. All works the same. So having said that, I hope that this helps to button down everything in 4.3. We're going to move on to 4.4 next. Thank you so much for watching.